Today's lesson is over deductive reasoning. Remember from our last lesson, inductive reasoning used examples to predict what comes next. So we were looking at patterns and examples to predict what came next. Where deductive reasoning uses facts, rules, definitions, and properties to draw conclusions. So we're looking at things we know to be true in order to draw a conclusion. Example 1, we're going to determine if the conclusion was based on inductive or deductive reasoning. At Holt High School, students must take English 1 before taking English 2. Sam is in English 2, so Maria concludes he has taken English 1. We have to ask ourselves, did Maria look at examples, or was she basing this on something she knew to be true, like a fact, a definition, or a rule? She definitely based it on fact. Students must take English 1 before taking English 2. Since this was based on a fact, she used deductive reasoning. So example 1A would be deductive reasoning. Then if we look at example 2 or example 1B, there's a myth that you can balance an egg on its end only on the spring equinox. A person was able to balance an egg on July 8th, September 21st, and December 19th. Therefore, the myth is false. So we have to ask, was this based on looking at examples, or was it based on a fact or a definition? This one was definitely based on looking at examples. A person was able to balance an egg on July 8th, September 21st, and December 19th. So this one is based on inductive reasoning because we were looking at examples to draw a conclusion. Then we have what is called the law of detachment. The law of detachment says if the hypothesis of a true conditional statement, so our conditional statement has to be true, and if our conditional statement is true, if the hypothesis is true, then the conclusion is also true. So that means if we're looking at a true conditional statement, if P then Q, if we are given the hypothesis, we can conclude that the conjecture Q is also true. So example 2 says use the law of detachment to determine if the conjecture is valid or invalid. So what the law of detachment says is basically we can detach the hypothesis from the conclusion. If we're given the hypothesis, then we know that the conclusion is also true. So this first one says if two segments are congruent. That is our hypothesis, if two segments are congruent. So for the law of detachment to work, the given statement has to deal with the hypothesis. So in this case, our given statement says segment A is congruent to segment B. So they did give us a statement about the hypothesis. Since they gave us a statement about the hypothesis, then we can conclude that this conclusion would be true. Then they have the same length. Well, the conjecture says that AB equals CD. That means that they are the same length. So this one is valid based on the law of detachment because I was given the hypothesis. This was our hypothesis. So the conjecture would mean that I could take the conclusion and I would know that it is also true. So I basically just pulled the hypothesis and conclusion apart. I detached them and made one of them a given and one of them a conjecture. One of them the hypothesis and one of them the conclusion. So this one is valid based on the law of detachment. If I look at example 2b, it says if two angles are a linear pair. That's my hypothesis. So my given statement would have to say something about two angles being a linear pair, because I'm going to pull that conditional statement apart, detach it, and I have to make sure my hypothesis is my given. And in this case, it is not. It does not say that angle A and B are a linear pair. It actually started with the conclusion, which says, then they are supplementary. So since this first part was not the hypothesis and they started with the conclusion, this would be invalid. So we have to definitely be given the hypothesis for the conclusion to be true or valid based on the law of detachment. So this one is invalid based on the law of detachment. So detachment, if you just think about pulling the hypothesis and the conclusion apart, except for they do have to come in order. You have to do P, then Q for your given and then your conjecture. Now we're actually going to use the law of detachment. So example 3 says, use the law of detachment to make a valid conclusion in a true situation. So this one says, if two angles are vertical, so that's our hypothesis. And I have to make sure then that my given is about two angles being vertical, and it is. Angle A and B are vertical angles. If I was given the hypothesis, then the conclusion is also true. Then they are congruent. So my statement then can say, angle A and B are congruent. Angle A is congruent to angle B. In example 3b, if the measure of angle R is between 90 degrees and 180 degrees, so that is my hypothesis. So that means my statement has to start with an angle being between 90 and 180, and it does. Angle R is 155 degrees. 155 degrees is between 90 and 180. Since I was given part of my hypothesis, the conclusion is also true. So I could conclude that R is obtuse. So I can say, so angle R is obtuse. The next law is the law of syllogism. The law of syllogism basically takes two conditional statements that are linked together so that we can make another conclusion. So here's how this works. If we have a hypothesis P, and it's if P, then Q. So I have a hypothesis P and a conclusion Q, and that is true. If I then make another statement that says if Q, then R. Since the hypothesis of the second statement started with the conclusion of the first statement, I am able to jump and say that P, if P, then R is also true. So the conclusion of the first statement then has to be followed by the hypothesis of the second statement for us to jump from P to R. So it's if P, then Q. Then I have a statement that starts with that conclusion. If Q, then R, then I can jump from P to R. So we're going to use the law of syllogism to determine if this conjecture is valid or invalid. And I like to color code to help me with this. So when I color code, I'm going to say if a number is divisible by 4, then it's divisible by 2. For the law of syllogism to work, I must start my next statement with if a number is divisible by 2. And I don't. It starts with if a number is even, then it's divisible by 2. Since I did not start it with the hypothesis of if a number is divisible by 2, this would be invalid based on the law of syllogism. This would be invalid. Okay, so B. We're going to start with if the measure of angle A is less than 90 degrees, then angle A is acute. So for the law of syllogism to work, I have to start with if angle A is acute, and I do. If angle A is acute, then it is not a right angle. So since the conclusion of my first statement matched with the hypothesis of my second statement, I can now jump and make the conclusion from P all the way to R. So I have to see if that's what happened. So my statement should say if the measure of angle A is less than 90, then it is not a right angle. And that's exactly what happened. And so this would be valid based on the law of syllogism. If possible, this time we're going to use the law of syllogism to write a new conditional statement. So we're going to look at the first one, which says if a quadrilateral is a square, then it has 4 right angles. So for the law of syllogism to work, my next statement has to start with that conclusion. If a quadrilateral has 4 right angles, which it does, we start with if a quadrilateral has 4 right angles, then it is a rectangle. So since our conclusion of my first statement matched up with the hypothesis of the second statement, I can now jump from P all the way to R. That is also then a true statement. So that's going to be our new conditional statement based off of the law of syllogism. So if a quadrilateral is a square, then it is a rectangle. Okay, now we're going to see if we can use the law of syllogism on B. B starts with if a number is divisible by 4, then it is divisible by 2. So for the law of syllogism to work, my next statement should start with that conclusion, and it does not. It starts with if a number is even, then it's divisible by 2. So since the hypothesis of my new statement right here did not match the conclusion of the first one, I cannot make a statement based on the law of syllogism. So I can't generate a new statement based on this.